Hey guys, it is week 2 of our distance learning, whether we like it or not. And I am just moving into, so we just finished up calorimetry, or we're kind of like starting to close up calorimetry. So before break, we were looking at putting a metal in cold water and then seeing how the temperature changed, using that to figure out how much energy was lost by the metal. So the last thing we're going to do is our Quantifying Heat Lab. So you have this paper. If you cannot find it, I have posted it underneath this video so you can print out a new one if you need to. But we are going to do the lab-ish. Okay, so I was not legally allowed to bring any of my chemicals home, so we're gonna fake it, but we're gonna walk through the procedure, okay? I did bring home a temperature probe, a lab quest from our classroom. It's upside down, but you get the idea. A lab quest from our classroom, and then we are going to essentially just pretend as though we're doing the lab, and we're gonna record data as it is expected, and then go from there, okay? So on this paper, let's start up at the top. It says, in this experiment, you will have the opportunity to measure and investigate the heat released as a result of 2 physical processes and use the temperature change to determine energy released and absorbed. So we're gonna essentially be doing, in this lab, we were going to be doing, basically just taking ammonium chloride, which is a white crystal, dissolving it in water. And then in a separate calorimeter, taking calcium chloride, which is again kind of a white, more of a powdery crystal, and putting that into the water and then dissolving them and see how the reactions affect the water around it. So again, we are going to be doing this in water. So reminder, it says here that the enthalpy change of the water is the opposite of what actually happened in the reaction. So if the water comes out to be a positive, the reaction was negative. Water's specific heat capacity is 4.18, so these dissolutions are happening in water, which is why we're going to use 4.18. Then we have both of our reactions here. Not exceptionally important for us right this second, but later in the year we'll see kind of maybe why this might have happened. All right, so it says we're going to measure out 4 grams of ammonium chloride and 4 grams of calcium chloride. Yeah, totally did that. It's right here off screen. You can't see it, okay? So it says mass of NH4Cl. I'm going to record 4.0 grams because I'm perfect and I didn't make a mistake, and it's totally perfect. So I've recorded 4.0 grams for both of those, okay? It then says place 100 grams of water in your calorimeter. Exactly 100 grams of water in my calorimeter. So it says place 100 grams of water in your calorimeter, place the thermometer inside, allow it to adjust, okay? So we're gonna write down the initial temperature of the water, and so I'm gonna let this go down. Dang, my tap water's cold. Refreshing. 20.3 seems to have leveled off. So let's record initial temperature of water as 20.3 degrees Celsius, okay? So that's the initial temperature of the water for the first trial. It then says add your ammonium chloride to the water and immediately begin stirring. Well, we are going to add our ammonium chloride to the water, okay? So I am using an insulated Thunder Ridge coffee mug. But we used in the classroom, we used the styrofoam cups stacked in each other, but doesn't matter. So I'm going to off screen, place the ammonium chloride. Oh, there it is. All right, cool. Now I immediately begin using the thermometer to stir it and swirling it around. And oh my goodness, it's getting colder, guys. It's getting colder. That's what ammonium chloride is supposed to do. So final temperature of the water, let's record as 16.4 degrees Celsius. So under number 3, I've recorded 16.4 degrees Celsius as the final temperature of the water. All right, so I am going to reset this. Back. So I put in another 100 grams of water. Now I'm going to put the thermometer in so that we can get the new temperature of this new water. I need to clean my kitchen. Okay, This one is starting at 19.4 degrees Celsius, so probably as the water is being pulled through the line, the water that is now coming out of the sink is probably coming from pipes in the wall from the outside, so that would explain why it's a little bit cooler. So anyways, so 19.4 is the initial temperature here. I'm going to go ahead and remove the lid and add the calcium chloride. Woo! Let's stir that one up. All right. Ooh, wow, the temperature's going up. Ooh, the container's warm. Well, hopefully not, because it should be insulated. But, oh, wow, the temperature's going up. Oh, goodness. All right. So the final temperature there, 25.6 degrees Celsius. Ooh, it was exothermic. Review. All right. Okay. All right. So it says rinse all materials and place them back neatly at your station. Yeah, I'm going to do that later because it's my house. I can do what I want. So go ahead and flip over to the back side of this paper, please. It says, in the space, design a data table that accurately shows all of your data from page 1. I do want you to do that because part of science, of course, is learning how to science, and that's what we're doing. So please design a data table there that puts all of the data from the previous page in there. It doesn't have to be elaborate. It can be pretty simple. And then work through your calculations. So you have your delta T, the mass of the... Now remember, in calculation number 1, I do want to point out something. It says calculate the delta H of the water. So in order to figure out the delta H of the ammonium chloride, we have to start by figuring out the delta H of the water. So the first step is to figure out how much energy did the water absorb, and then we can use that, make it negative. That tells us how much energy the reaction may have given off, okay? In this case, it was an endothermic reaction, so we'll see that the delta H of the water is going to be negative, and then the delta H of the reaction will likely be positive. So don't fake it. I want you to make sure you can do that, but the delta H of the water should end up being negative. The delta H of the reaction or the dissolution should be positive. Wow, that is not a good angle. All right, so calculate that, and then it says, is this reaction endo or exo? Well, you can always just roll the tape back. And then what I'd like for you to do for the post-lab analysis, obviously, this is not exactly what we would have used in class, but the answer is still true, okay? Think about whether or not this insulated all heat, was all of the heat that was either gained or lost by the reaction instantly gained or lost by the water. Or could it possibly have been lost somewhere else? Could it have been absorbed by something else? I don't know. Okay. So this is one of the assignments that you will be submitting for week 2. So once you run those calculations and set up your data table, then go ahead onto Google Classroom and you can post it. If you want to just download the digital copy of it, make a copy and then submit it that way, you are welcome to, or you can submit it as a picture. Either way is fine with me. I will be looking for a neat and accurate data table. I will be looking for calculations with units. And I will be looking for correct answers for 1B, 2B, and the post-analysis number 1, okay? So think a little bit in depth about energy transfer and what real energy transfer is and what, transfer of energy can be affected by, all right?